Hello, everyone. So today we'll be talking a bit about observability and how in Molly we scale observability and try to keep our costs under control, which is always the fun challenge, right? I'm Diogo. This is Andre. This is our contacts if you want to reach out for some reason. And without further ado, for those who don't know, I'll just give a brief introduction about Molly's fintech company that provides money management solutions for businesses all across Europe. And yeah, today we'll just go over this big problem that is observability and scaling observabilities and not scaling costs. So we'll contextualize the problem, talk you about our implementation journey, and showcase some of the experimentations or more recent developments that we did with it and summarize the key learnings because we are all here to learn. And yeah, if we have time, do some Q&A. So Molly is not a new company. It was founded in 2004, but its growth got very quick in 2019 with the first funding round. So it started scaling rapid growth. So for context, we scaled from 100 people to over 800 now. And from all of those, like 40% are around engineers. So it's a big engineering company. And we came from a place where observability was a shared responsibility. There was no standards. And costs were obviously rising because we were using an expensive vendor. To put into perspective, it was almost like 15, 16 years of like share responsibilities. With the growth, it made sense that we needed a team to take care of reliability and take care of the standards, take care of the platform, and provide a strategy. So, yeah, we now have a team, a dedicated group of engineers to tackle this problem. So the solution is simple. Let's like just start educating teams, promote a cultural change. Let's create all the nice standards that we need, and let's fix everything on the source, right? Not really, because we're talking about a lot of history, a lot of legacy, and the team was not that big. So there was capacity issues with coordination. Imagine coordinating like 40 engineering teams with one small team that now tells you, no, you can't do observability that way. We have an historical big PHP monolith, so attribution was complicated. There was a lot of abstractions there that continue to exist still. And we also have mega module for infrastructure. So infrastructure was self-provisioned to teams through a module. Observability was still in this module as well. So velocity and isolation in version upgrades was hard. And with all these issues, there was starting to get an history of like frustration engineering where we had people come over, try to solve this problem, costs were still rising and adoption was lacking. And with frustration, like people left the team. And so it was a constant like back and forth on trying new things. To put into perspective, this was the old way that we were introducing observability changes. So we had a version increase in our infrastructure model, renovate kicks in, every configuration for infrastructure for all the services starts being updated, and then you have the changes go to production, right? This can take more than days, weeks when we're talking about all the services that we have on Molly. So it was not scalable and costs were still rising. We have more teams, features were still being developed. We couldn't hinder our developers' velocity, nor should we. It was not their problem. Although that's the chair responsibility, they are there to develop features. And Molly was in expansion. Like we were expanding throughout Europe. We needed to change this model. And so we got back to designing and getting the requirements that we need. So our solution and our key like points, what we want is let's just do fire and forget. Let's not complicate everything on the code because that has proven not to be scaled to roll out. Let's stop our external dependencies with teams. We want to make a change. It needs to be quick and depend solely on the reliability team. And let's keep migration efforts to a minimum because no one likes a good solution. And if it doesn't see the light of day on production because there was too long of a migration. And again, like these solutions should provide data transformations because again, we're doing it from a central point. And this was the model we came up with. So we basically designed a central pipeline for all of our telemetry data. And this way we could do change configurations on a single infrastructure project. And this would be changed on the services live in code. So there was no like module upgrades nor anything like that for these sorts of transformation. So change that would take us like weeks to see in production. Now took us minutes and take us minutes actually. You can see our provider, so we can imagine the types of costs and cost structure we're dealing with. It has great features, but expensive. So we needed to fight it. So sorry. The solution for the underlying like technology stack that we chose was Vector, and this was a very strategic choice. At the time, Vector was bought by Microsoft, so compatibility was not an issue there. It's open source, high performance, it's built on Rust. And like Hotel, it has a push-based approach, so we don't need to waste resource on call-based, like trying to collect data. It has a lot of integrations for sources and for syncs, so we can mix and match. So we can have the Datadog agent provide you like the Datadog format, and you can export it to all formats. And it has built-in functions to transform data. So it had all our requirements. And now comes the GNL. It seems very good, but it was like, it still took us a bit of time to get it there. Back in 2023, we did our first proof of concept. So just start to see if it was actually functional. It was. So we tried to put it in production, but we had migration issues. And these issues were mostly caused by we took it too quick. We experimented and just saw it from a team's perspective. There was not a formal value analysis. And at the time, we were still doing this migration with all our infrastructure models for observability tied within the main infrastructure model. So it was hard to also scale this on the infrastructure level. And the rollout was too quick. So we started having an outage on non-critical systems that quickly scaled to the critical systems. So everything was pulled back. And we did a big reevaluation of what we wanted with Vector and how we would do it. So first thing first, we set a quick deadline. So we were not going to waste more time with this solution if it was not feasible in production. So we set our times in a date, early 2025, to either continue with the project or completely pull it off because we had a team that a lot of engineers dedicated to this project and it was like quite expensive in labor. What did we do different? I have a mouse here. Okay. Sorry.
Probably laptop.
I'll just. Sorry. Okay. And I probably. Okay.
Is the laptop.
Okay. So what did we do different? First, we set out a deadline to fully evaluate or cut off the project. We start separating our services from based on criticality or core and non-core services. And we did a lot of investigations. Like we thought we undervalued the capacity of Vector and we undervalued the migration efforts that we took to do it. So there was a lot of investigation, a lot of investment in managing and capturing data because we could not make decisions if we did not have the right data. We also took out all our infrastructure models from the main Terraform module because we needed full isolation for this and we needed control on our team. And we did a lot of work on production readiness and rollout procedures. And we did phase approach on onboarding. Even with critical projects, we did it in a phased approach. This is like the underlying architecture. We kept it very simple, 2 node pools. we have internal node load balancers, and we separate the ingestion from telemetry based on if it's a critical project or if it's not a critical project. And yeah, we scale it with Kubernetes. Nothing too crazy there. But now getting vector to production, that's another story. Rest should be like super easy. Memory should not be an issue. And it wasn't. Like our pods were behaving properly. We did not have outages in terms of memory or anything like that. But the first thing that we started seeing in some of our projects was dropped events. And somehow we saw some correlation with the lag. So lag is the time between an event reaching our vector pods and the time it was like the event was emitted by an application. So what we did here turns out like lag is completely dependent on the utilization. It is the load on our pods. So what we did is we increased the capacity. So we scaled it more than we had first anticipated. And as you see, if we have a lower lag and we have more manageable like utilization, we started having like less events of dropped events. So this was the first change. And as you can see, the time we took to process fully a request also diminished a lot. And we started seeing much more activity in our sinks, which is like the pods that send out data to Datadog. The second issue, which was quite surprising, we were not having memory issues. And we thought like our biggest problem would be memory because our vector behaves, it's a bunch of memory buffers, essentially. So it buffers like events throughout different transformation cycles. But the biggest problem that we had was CPU throttle. We noticed that CPU throttle through activity was actually the main cause of these missing events and dropped events. This was a Datadog outage, so it doesn't count. So what we did was actually like, let's give it like some beefier nodes and also performance tuning. What we did like with this, we did not fix lag. Like lag was already like at the minimal levels, but we did get much more stable RTT. So between the sinks and our final destinations. And this is our current performance status. So it's much more stable, much more performance. And as of that moment, we did a full rollout, minimal downtime, no big disruptions. And we made a decision, even if it's like with all the costs of running vector, like all the maintenance costs, we saw a lot of intangible value out of like just being able to do like a change in all our production services within minutes without having any dependence on other teams. And like you saw, like vector can connect to a lot of different sources. So we can have dual syncs, so increase reliability. Let's say that outage you saw in Datadog, let's just sync it all to a Prometheus instance, for example. And also, yeah, it allows us to, we are using an expensive vendor. It wants to like be fully compliant with Othel. We cannot do it with all the service. Like the problem is like when you change the monolith, we have to change all the service. We can like do focus project groups on these efforts without having to disruption on the others because we have a pipeline that controls all the other data. So we can route this data all and out like different routes. And with these decisions, we started like more recently doing experiments and trying to get some value out of it, not only from the intangible, like tangible value. And for that part, I'll give the words to my colleague.
I have the mic over here. Thank you. So this is working. I see the green blinking light over there. So before all, morning to everyone, to the ones I haven't met. Diogo, can you skip this slide? So regarding what our solution is currently at Molly. So at first, like Diogo said, the costs were increasing, okay, very rapidly. And of course, this is not the only problem, as when you have tons and tons of metrics, it hinders the UI experience. So for example, if a given on-call engineer needs to reach out to a given metric, he needs to go out into a set or a huge set of pages of metrics. So our philosophy here was very simple, yet very powerful. We wanted to filter unused metrics. So filter the data that you do not use, right? This is the first step to try to reduce costs, right? So we had around, or we found out that we had around close to 250K metrics that had not been queried for the last 30 days, and not just this. And once again, not used in any asset. And what we mean here by any asset is dashboards, monitors, SLOs, and others, okay? So regarding the implementation of what we currently have in our observability pipelines at Molly, we are using Vector, like Diogo presented before, and we implemented the whole pipeline using VRL, so Vector Remap Language, which is a domain-specific language from Vector. And in here, we followed an approach on a double sync, as you can see. So we have here 3 groups. The first one in the left is the sources, the middle one is the transforms, and the righter one is the sinks, okay? And as you can see, we have a double sync. So we have a deny sync, where we send out the metrics that have been denied, and we have an allow sync that sends metrics into Datadog. As you can see, the deny list for now sends the metrics into a black hole, which is a type of sync from Vector, and this is into the void or into the oblivion, okay? And regarding sources, we are extracting or fetching data from internal metrics. And not only from this, also from the Datadog agent. We can, for example, include here many things. And for example, in the version 50, the 0.50 of Vector, they are including hotel, scrapers, etc. Okay. And regarding the pipeline, as we can see, the first step that we have in there in the transform section is the ingestion check. So in here, we are just doing a very simple approach. It needs to be scalable, right? And in here, we are just looking up into 2 different tables. So one is the non-negotiable metrics list, which is a kind of metrics that you want to go through and let them pass no matter what. And we have also the deny list, which is the list of metrics that you want to deny, right? And in here, we are just tagging them. So we had a kind of Boolean value tag over it. So if it is to be dropped, we had a tag to the event drop through, right? If we want to non-deny it, or if you want to allow that, or to deny it, sorry, we want to have the tag drop false, okay? So right after this, we send it to the next transform in line, which is the route metrics. And in here, we are only again using a very simple yet powerful approach. So we are handling data at scale, and you are going to see the amount of data we are dealing with. And in here, we just have a simple if-else clause. So if a given event has a tag drop set to true, we route them into the deny sync or into oblivion. And if we have it set to false, we allow it to the next bar in the pipeline. Can you just click 3 times in order for us to, yeah, exactly. And this last one, the clean drop, we are just doing a simple operation, which is just to clean the drop tag, because if you have more tags into your events, you are going to pay more, right? And yeah, after this, we route it to the allows. Go ahead, Hugo. And in here, we had the automation of the ACL, so access control list generation. So in here, you need to have 2 lists, the deny list and the non-negotiable list, right? And as you can see, this is just a simple Simon Brown C1 level. So for context of our application on end-to-end over here. So we have the Datadog, which is an external monitor and observability system, as you all know about. And we have the observability data pipeline here in the bottom left. So it controls the metrics ingestion process. It implements the logic that we saw using VRL. It sends the filtered metrics into Datadog, okay? And we added here one more component, which is the metrics explorer, which right now it's a Go client that we have implemented that collects metrics from Datadog, produces the lists, and then publishes the lists into a given bucket in Google Cloud Storage in our implementation. One thing to note here is that when this metric explorer publishes the list of metrics, we have the capability on Vector to do the hot reloading. So in production, we don't need to restart pods. It hot reloads the configuration itself in runtime, and we are, again, with a new version without needing to redeploy the whole thing, okay? Because we are at a big scale. Go ahead, Yo, hit the next slide. Oh, before one. Oh, no, this one. This slide is what probably people are very curious about over here. So at Molly, we are handling around kind of 68.4 TB daily, okay, only on custom metrics. So this is a good scale, I think. And with this operation, or with this simple approach, with this simple philosophy of cleaning out what you don't use, we are now cutting in raw about 38% daily. So 26.2 TB bytes out of the 68.4, okay? And regarding costs, here in the left side, you have a plot where we can see the whole picture from 1 year backwards. So we have 2024 November till now. And as you can see, like Diogo said, costs have risen up a bit. As you can see, the trend line is upwards, right? And as you can see, we started denying or applying our solution at the 23rd of October, so last month. And as you can see, we already have a sharp drop in there. We are cutting about 30% in our custom metrics costs at Datadog. And this is not only the benefit of it. Of course, everybody wants to pay less, right? But in the end, we are going to have a cleaner metrics list, which is good for everybody, right? If everyone is on call when you are needing to scrape metrics and search for them. And of course, also, and I think this is the very top pro of this solution, is that we now have control of everything. Every single byte regarding telemetry and regarding custom metrics passes through our pipeline over here, okay? Diogo, back to you again.
Yeah, so this was like 1 month work. We never in our 5 years path, like in the team, had such a big value on such a short amount of work. So it proves the scalability of the solution. But I wanted to summarize some learnings on how we got there, because this might not apply to every business, but we did learn a lot of things in the process. So the first thing is be mindful of your users. So our users was engineers. They didn't want a lot of changes in their code, nor they would care about cost. So we need to provide something that would take out that responsibility from them. Be data driven. So all of this is only possible if you have good insights and can know when to scrape a solution or go forwards. To conduct retrospectives on your team, just to probe capacity and frustration. This solution came out of a lot of frustration engineering, so that is helpful. And we do this periodically to see if we want to continue or not with some solutions. And again, like focus on incremental deliveries, like big rollouts might be good, but they can be very risky. They can provide a lot of risk. This solution, like the re-evaluation that we did on the project, allow us to roll out smaller but continuously. So we would be able to evaluate the value that we had up until that point, and can see if what we are doing can continue like to be a good approach. Okay, so if I were to summarize, this was my like 4 biggest learnings here. And yeah, with that, I don't know if you have time for Q&A, but thank you all for the time, and we'll be here throughout today. So
2 minutes for
2 minutes, right?
questions. So if you have a question, raise your hand and I'll go there and give you the microphone. Questions going once? There we go.
Instead of just dumping data that some director later could be asking for, could we just summarize the metrics instead of having metrics like every 5 minutes, every 1 minute, like this metric per month or per year, and still save that data for later research?
so
Vector has that. Was it?
yeah. So now we just like what we don't want to be dumped down, but we're actually
Later
doing
a
like
director will call you.
yeah. So now the current next iteration is actually we're refactoring that black hole sync, and we're using it for a local observability, and we're going to conserve that data exactly for audits, investigation of like past issues, and exactly for the reasons you've mentioned.